I'm going to tell you about the directions for the red shift versus blue shift. Go to the back table, the resource table, and get your worksheet. And it's going to look like this. Okay. This actually looks identical or very similar to the bottom of the practice page that we're going to use to do this. So using the website listed below, read everything from top to bottom and answer all your questions. Add information to your notes and make new study cards as you need them. This stuff will be on your test. If you need any help, just call a teacher over. We will help you. Okay. So when you click this link, it'll take you to this website. Read top to bottom. This website can be translated as well. If you don't read it carefully, you're going to miss out on things. This is all straightforward. You can try all that, read all this, but then at the bottom, I want to run you through the directions for this part. This is what I wrote out on your worksheet here, but I'll show you what I mean. So on the website, it's going to tell you this is where you're going to practice. So I'll do the first one for you. It says drag the red circle to the star you want to analyze. So there's 7 stars. Can't analyze every single thing, just the ones that are there. When you do, the star will pop up. Now, this is the star that you are looking at in the sky. What you're going to do is you're going to compare that to some standards, some known emission spectra that come from looking at different elements, gases in the lab. So first you have to determine what element is this star made up of. Well, if you compare them, is it neon? Definitely not. Similar. Is it helium? Looks close, but there's no yellow line. So that means that it's hydrogen. So first, you already determined that star 1 is hydrogen. And then you're going to write that down on your note sheet here. You can put an X, you can put a check, whatever. Then, the light from your star passes through the telescope into a spectrometer that shows you an emission spectrum. Compare the emission spectrum with the known element to determine what the star is made of, and then to tell whether or not it is red shifted or blue shifted. So here it's very important when you do this, you have to make sure that they are lined up perfectly. You can either line them up on the line, or I like to actually line up 2 title boxes. Now, as you can see here, the star you are looking at, when compared to what you know hydrogen is, the lines are definitely not even. They're shifted. Now, which way are they shifted? This hydrogen is what hydrogen looks like without it moving. This is the star, and it's clearly shifted. Is it shifted toward the red side of the spectrum or the blue side of the spectrum? Now you have to remember that when you're looking at this, you have to remember that the red side of the spectrum, blue side of the spectrum, although it might not be up and down, we can still use that to tell. So then we know that this emission spectrum shows that red is up here and the blue end will be down here. Well, which way are the lines shifted? Are they shifted up towards the red or down towards the blue? Well, look, compared to what we know hydrogen looks like, they're all shifted up towards the red, which means that they are red shifted. And we know that when they're red shifted, the wavelengths are getting longer, stretching out, so that means it's moving away. Yep, awesome. If you have questions, just ask.